Hey there, grade 9s. Welcome to lesson 3 of chapter 4. In this lesson, we're going to be talking about using other forms of equations for a linear relationship. So just a reminder, a linear relationship is something that we can graph where we have a constant change. So it's going, just the graph itself would be in a straight line. So normally what we would have is we would say y equals 2x plus 3. So this is what we were talking about last time. So if I was to graph this, I have a positive numerical coefficient, which means my graph is going up from left to right. Okay? My constant is telling me where I'm crossing through, and then for every time it goes right 1, it goes up. So my line might look something like this, assuming that this is at positive 3. So my intersect on my y-axis is at positive 3. Now, what if, for example, we were not given both variables? Okay? So what if we were given something that would look like this? If it just said x equals negative 4 or y equals 5, positive 5. Okay? What would these look like? Okay, so we basically need to assume that we only have a single straight line. Okay? So basically what we're saying is if x equals negative 4, that means y equals 0. Okay? So if x equals negative 4, y equals 0. Okay? So I might go x equals negative 4, and then y might be 0. Okay? And this is the type of a relationship where it's just going to be going straight up and down. Okay? Because no matter, if we don't have a y, no matter what, our x is going to be at negative 4. Okay? So no matter what we put in for our y, so if we put in 0 or 1 or negative 5, okay, any one of those situations, my x is going to be negative 4. Okay? If I'm looking at this other one here, where I have my y equals positive 5, so 0, and so my positive 5 is going to be here, this is going to be a relationship that's going to look something like this, where it's just going to go horizontally. So basically, I don't have any information for my x, but it's all, my y is always going to be at negative 5. So this is the constant. So what can change is my x can be at 0, it can be at 1, it can be at negative 5, it can be at 12. My y is always going to be at positive 5. Okay? That's exactly what this kind of relationship is showing. Okay? Is we're showing that when we're saying there's only one variable represented, we're saying that this is equal to this. That means it's always going to be equal to it, no matter what the other value is going to be. Okay, so that's how we get our straight line. So if we have negative 4, doesn't matter what our y happens to be, it's going to be a straight horizontal line. Okay, vertical line when we have what our x equals, and a horizontal line when we know what our y equals. Okay, so that was kind of the first one. Now this next one takes a little bit more calculations. Okay, so what if we have something that's represented by the equation where we have ax, and then it can be plus or minus, by equals c. Okay, and I'll explain what this kind of means. So this is something that we can still graph. Okay, so let's use the example like this. So if we have 3x minus 2y equals 6. Okay. If I'm making for myself a table of values, okay, so I'm going to say if x equals something, what does y equal? Okay, in this particular question, it's giving me particular things to find. So I'm going to look for negative 4, 0, and 4. If I know what these coordinates are, I can technically graph this equation. and I can actually calculate where it's going to go. So the first thing I'm going to do is I'm actually going to take my -4 and I'm going to substitute it in. So I'm going to have 3 times -4 because my x is being replaced with -4. Minus 2y equals 6. Okay, this is going to give me -12 minus 2y equals 6. I need to add 12 to both sides to eliminate this. Okay, so now I have -2y equals 18. I need to divide both sides by -2. Okay, this cancels each other out, so y equals -9. So when I go back to my my graph over here, I'm going to have somewhere on my graph, okay, and if I start to draw my graph now, okay, let's say we're going something like this. This will be -5, -5, 5, and 5. Okay, so at -4, let's use blue to graph it. -4 is going to be down here at -9. Okay, so this ordered pair is -4, -9. Okay, and I'm going to see, hopefully you guys can see that, yeah. Okay, I'm going to see where that can take me. So that was my calculation for my first one. Now I'm going to do the second one with 0. Okay, so let's see what I get when I put 0 in for x. So 3 times 0 minus 2y equals 6. So this is going to be 0, so I'm going to be left with 2y equals 6. And then I'm going to divide both sides by -2. Okay, so y equals -3. So when I look over here, I've got -3. So at 0, I'm going to connect at -3, and I can start to connect my line now. Okay, let's check the last one. So at +4, where are we going to end up? Okay, so 3 times 4 minus 2y equals 6. So this is going to give me 12 minus 2y equals 6. So I need to subtract 12 now from both sides. Oops, this is going to give me -6. This is going to cancel out. So I have -2y equals -6. Divide both sides by -2. So those are gone. So y equals 3. -6 divided by 2 gives me 3. So now I've got 4 and 3. So my last one is going to be at 4 and 3, somewhere around there. So I try to connect those lines. Okay, so I'm still able to graph this entire expression. Okay, can I come up with another expression to graph it? Well, yeah, probably. What would it look like? Okay, well, I know that it's crossing through at -3, so -3 is going to be my numerical coefficient. And then basically what I'm doing is I'm trying to calculate my rise over my run. So as it goes up by, well, in this case it goes up by 6 over 4, so it's going to be 1.5x minus 3. Okay. So what did I do there? I basically calculated the difference from, so here I've got 0 and -3, okay? And then here I have 4 and 3. I'm calculating the distance in the rise, okay? So I have -3 to 3 is a distance of 6 over my run, okay, which is 4. So rise over run, and then I just try to simplify it, which gives me 1.5. Okay, so 1.5x minus 3. So this expression is actually the same as this. All right? So we do have the ability, once again, like I said, you can actually put in certain numbers to calculate what it is and be able to graph those expressions. I wouldn't necessarily expect you to look at an equation like that right away and be able to graph it immediately. Okay, we haven't gone through that type of process. Okay, if you have any questions, once again, please bring those questions to the Zoom or contact me through Hangouts. All right, have a great day. Good luck.